Good day everyone! Welcome to the video lesson on Module 10 about evaluating combination notation. I hope you are ready and excited about our lesson for today. At the end of the lesson, you are expected to evaluate combination notation. Before we proceed, please answer the pretest to check your readiness in the lesson. You may pause the video while answering, then play it once you're done. Direction: identify what is being asked in each question. Write your answer in your paper. Now, check your answer. Let us have a recap on what you have learned on the previous lesson. Direction: represent the following problems in combination notation. Number 1. Mrs. David made 10 questions for her students to answer. If the students are asked to answer only 5 questions, in how many ways can the student choose the question? Correct. The combination of 10 taken 5 at a time. Number 2. From a population of 50 households, in how many ways can a researcher select a sample with the size of 15? Correct. The combination of 50 taken 15 at a time. Number 3. A delegation of 4 people is to be selected from 5 women and 6 men. Find the number of possible delegations if there are at least 3 women. Correct. The combination of 5 taken 3 at a time times the combination of 6 taken 1 at a time plus the combination of 5 taken 4 at a time. Now, let us go to our lesson. Can you still remember this problem in the previous lesson? How many 3-letter combinations can be formed from the word math? We solved this combination problem by relating it to permutation. Let us take another look at the arrangement shown in this table. Notice that the set of different combinations formed is the subset of the set of permutations. Let us take this set of combination. The equal sign means that the arrangement is counted as 1, since in combination, arrangement is not important. Each combination of 3 letters determine 3 factorial or 6 permutations. Therefore, we can say that the number of combinations multiplied by 3 factorial gives the number of permutation. Using this equation, let us look more closely how combination is related to permutation. If we're going to divide both sides by 3 factorial, it will give us this equation. What does 3 factorial mean in relation to the problem? Why do we need to divide it by 3 factorial? This is to count the arrangements of the same group as 1, since they are already counted in the permutation of 4 taken 3 at a time. From this equation, let us derive the formula for combination. Solving for the combination of n taken r at a time is equal to the permutation of n taken r at a time divided by r factorial. We all know that the permutation of n taken r at a time is equal to n factorial divided by the quantity of n minus r factorial. Simplifying this fraction, let us multiply both numerator and denominator by the reciprocal of the denominator, which is 1 over r factorial. Simplifying further will result to this combination formula. Let us use this formula in solving different problems in combination. Example 1. Evaluate the following combinations. Letter A. The combination of 9 taken 6 at a time. To evaluate this combination notation, all you have to do is to substitute the value of n and r to the formula, then simplify. Start with the quantity of 9 minus 6 factorial in the denominator. The expression becomes 9 factorial divided by 3 factorial times 6 factorial. Express 9 factorial as factors of 9 times 8 times 7 times 6 factorial. Dividing these two factorials will result to 1. The 3 factorial in the denominator can be expressed as 3 times 2 times 1. Then performing the operation, the result is equal to 84. Letter B. 4 times the combination of 20 taken 20 at a time. Again, to evaluate this combination notation, all you have to do is just substitute the value of n and r to the formula, then simplify. Let's start with the quantity of 20 minus 20 factorial in the denominator, and that is equal to 0 factorial. We all know that 0 factorial is equal to 1. Simplify 20 factorial divided by 1 times 20 factorial, then multiply it to 4. And the final answer is 4. Example 2. Find the unknown variable. Letter A. The combination of n taken 2 at a time is equal to 21. We can solve the value of n in this equation using the combination formula. Substituting n and the value of r will give us this equation. Simplifying, let us express n factorial as factors of n times n minus 1 times n minus 2 factorial. Dividing these 2 factorials will result to 1, and the equation becomes this, or simply this. Simplifying further, let us multiply both sides of the equation by 2. So the equation becomes n times the quantity of n minus 1 equals 42. Applying the distributive property of multiplication, the equation becomes n squared minus n equals 42. Equating this quadratic equation to 0 is equal to n squared minus n minus 42 equals 0. Solving for n, let us try to factor this. And the factors are n minus 7 times the quantity of n plus 6 equals 0. Equating each factor to 0, then solve for n. So n is equal to 7 and n is equal to negative 6. There are 2 values of n. We will get n equals 7. Since factorial is a product of positive integers, we consider negative 6 as extraneous root. So n is equal to 7. Letter B. The combination of 11 taken r at a time is equal to 330. Again, let us use the combination formula to solve for r. Substituting the value of n and r, we will have this equation. To simplify, let us multiply both sides of the equation by this number. Doing this, we will have now this equation. Notice that the right side of the equation is a product of 2 factorials. Our objective now is to express also the left side of the equation as product of 2 factorials. Working on this, let us get the factors of 11 factorial and 330. From here, perform division. The remaining factors can be written as 3 times 8 times 7 factorial. 8 can be factored as 4 and 2. 3 times 2 times 4 is also the same as 4 times 3 times 2 times 1 and can be expressed as 4 factorial. The left side of the equation is now expressed as product of 2 factorials. From here, we can solve now for the value of r. Equate 7 factorial to 11 minus r factorial. Simplify, then solve for r, and r is equal to 4. Or, equate 4 factorial to r factorial. Solving for r is equal to 4. Then, equate 4 factorial to 11 minus r factorial. Solving for r is equal to 7. Or, 7 factorial equals r factorial, and r is equal to 7. Notice that there are two values of r that will satisfy the given equation, and those are 4 and 7. Example 3. Solve the following problems. Letter A. Mr. Lucas planned to conduct an intervention program for the 20 students at risk in mathematics. In how many ways can the teacher select 5 students at a time? First, express the problem in combination notation. And that is, the combination of 20 taken 5 at a time. To evaluate this combination notation, substitute the value of n and r to the formula, then simplify. So the combination of 20 taken 5 at a time is equal to 15,504. Letter B. 5 different letters are chosen from the word education. How many of these choices contain at least 3 vowels? The combination notation of this problem is this. Using the combination formula, evaluate this combination notation, then simplify. So the final answer is equal to 81. Letter C. A concert pianist agrees to take part in a charity concert for COVID-19 patients. She offers a choice of 9 works, of which 4 were composed by Chopin, 2 by Liszt, and 3 by Schumann. Calculate the number of ways these 4 works can be selected if there are 2 works by Chopin, 1 by Liszt, and 1 by Schumann. In combination notation, the problem can be expressed as this. By combination formula, evaluate, then simplify. The final answer is 36. Now, let us have a wrap-up on what we have discussed today. Remember that the combination of n objects taken r at a time is equal to n factorial divided by the quantity of n minus r factorial times r factorial, where n and r are positive integers and r is greater than or equal to 1 and less than or equal to n. Other notations can be written in this way. Valuing. When the number of items is large, it may be troublesome to find the required number of combinations by using the counting principle. Mathematicians have derived a formula that is easier to find the number of combinations in such cases. But knowing how these formulas work is only half the battle. Create a formula that you can use to cope up with the new normal we are facing in the education because of the COVID-19 pandemic. How can this formula help you to achieve your goal this school year? Post-test. You may pause the video while answering, then play it once you are done. Direction. Identify what is being asked in each question. Write your answer in your paper. Now, check your answer. Activities. In each activity, you may pause the video while answering, then play it once you are done. Activity 1. Let's practice. Evaluate the following combinations. Now, check your answers. Activity number 2. Keep practicing. Find the unknown variable. Now, check your answers. Activity number 3. Test yourself. Solve the following problems. Now, check your answers. That's all for this video lesson. Thank you and keep safe, everyone.